So pardon me about the lighting. I hope that you really enjoyed my first lesson of introduction to gradients and equations of a straight line. But in this particular lesson, I want us to do something a little bit involving and something you can have fun doing at home. So what I want us to do is to look at to get the gradient of this line that I've drawn right here. My line A, B is right there. So it's a line point from 1 and B at point 4, 6. So this is the first point. So I'll call it point 1, and B is my second point. I'll call it point 2. And in regard to that, and taking you back to Form 1 work, you used to call these, or when we said that the points on a Cartesian plane, they are given in what we call coordinates x, y. So the coordinates in point 1, I'll call it the first x, so x1, and the first y, y1. And the second point will be x2, and the other one will be y2. So when it comes to calculating the gradients of a line on a Cartesian plane, we usually say that gradient should be equal to change in y divided by the change that takes place in x. And that will mean y changing from 1 to 6 and x changing from 1 to 4. I think that we can say. So when I'm talking about the change in y, I'll say my gradient, in this case, my gradient should be equal to the change, and that change is actually the difference. It's good we understand that the change is the difference, which means it is my y2 minus y1. I divide by my x2 minus x1. That way, as simple as that. I'm hoping now we can see it. So I have y2 minus y1, x2 minus x1. I'm really struggling to get this, but then we can continue. So in this case, I'll only have to write my coordinates again, and this time right down here so that I can get them working. So I'll have my point A, which is 1, 1, according to this, and my point B right here, 4, 6. So my point 4, 6. Good. So this is my first point. So that is x1, y1. This is my x2, y2. And I'll say my gradient should be equal to y2 minus y1, x2 minus x1. So in this case, I'll say I have my y2 is 6, so I'll get 6 minus y1, which is 1, divided by 4 minus y1, which is 1. And I'll leave my gradient to be 5 over 3. I leave it at that. I know it's simple, but let me just go through the whole process once again. And I'm starting right here. We're getting the gradient of the line AB. So my point A is at point 1, 1, that we can see, and my point B is at point 4, 6, that again we can see. And this is my x1, y1, my x2, y2. That is good, we can see it. And then from there I'm saying gradient should be equal to change in y divided by change in x. And I've said very well, the change, we get it from this, where along the y-axis I'm moving from value 1 and I'm going all the way to value 6 right there. And when it comes to the y-axis, to the x-axis, I'm moving from value 1 and I'm going all the way to value 4 right there. So this changes. This is a change and there's a transition. So that is exactly what we're looking at, and we're saying, or we're calling them change in y over change in x. And that change I've clarified and said that the change itself is actually the difference. So the difference of my point 2, the value of y in point 2, I subtract the value of y in point 1. So y1 minus y2 minus y1 divided by x2 minus x1. Then I don't mind writing my values down here, where my a was a 0.11 and my b was a 0.46. So the gradient becomes 6 minus 1 and divide by 4 minus 1. So that's my very final gradients become 5/3, and we can see that. So that is all for now. Until our next lesson, please try doing that with your family, with your friends, and we are good to go.